Continuing with the arithmetic second part. Today we are going to cover number system and see how the questions on number system are asked. So there are three things: factors, remainders, and the maximum power. The concepts with GMAT tests are divisibility, prime factorization, and the counting factors, or how many number of factor does a number have. So let's move on with the lecture. Let us discuss what is a prime number and what is a composite number. So any number which have only two factors, 1 and itself, is called a prime number. On the other hand, the numbers which have more than two factors are called composite numbers. If I say 1, it has 1 as a factor and it has itself as a factor, but it does not have two factors and thus it is not prime. And even it is not having more than two factors, so it is not even composite. So one is neither prime nor composite. Some key points. Remember, I told you smallest prime number 2, only even prime number 2. One more thing, there are 25 prime numbers in first 100 natural numbers. You can go through them, pause the video and go ahead. Okay, so let us talk about factor and divisibility. If a number, say A, is divided by a given number, say B, and the remainder comes out to be 0, then the given number B is the factor of the number A. For example, if I say factors of 32, when 1 divides 32, the factor or the remainder is 0. When 2 divides 32, the remainder is 0. Similarly is the case for 4, 8, 16 and 32. Hence, 32 has these numbers as its factor. Let's go deeper into the concepts and try to learn the divisibility test. I will recommend pause the video, go through the information given here, read them, and then move ahead. Right now, I will take you guys to the whiteboard where we will discuss about the divisibility test. So talking about the divisibility test of 2, it's very simple. If the last digit is divisible by 2, the number is divisible by 2. Similarly, is for 4, just instead of the last digit, I have the last two digits. If the last two digits are divisible by 4, it is divisible by 4. Goes with 8. Instead of last 2, now last 3 digits. So 2, 4, 8 and 16 almost similar. Last single digit, last 2 digit divisible by 4, last 3 by 8 and last 4 by 16. Now talking about 3 and 9. Again kind of similar. If I say 3 and suppose the number is 1, 2, 3, 4, 5, add up the numbers. So here 1 plus 2 plus 3 plus 4 plus 5, it gives me a 15. And 15 is perfectly divisible by 3. Hence the number 1, 2, 3, 4, 5 is divisible by 3. Similarly is for 9. Write down the number, add them up. If the sum is divisible by 9, then the number is divisible by 9. Let us move ahead and check for some more numbers. So talking about 11, if I have a number such as 1, 2, 3, 1, 2, 3, just add up the digits at even places and add up the digits at odd places. So I have 1 plus 3, that is 4, plus 2, 6. Then I have a 2 plus 1, that is a 3, and 3 plus 3, that is a 6. Subtract the sum. If the answer is 0 or divisible by 11, then the number is divisible by 11. So 1, 2, 3, 1, 2, 3 is divisible by 11. Now let us go to the 7th divisibility test, a little complex but not used much. For example, let us test it on this number, which I already know that is divisible by 7. So it's very simple. Just truncate the last digit, multiply it by 2. So 4 2 gives me 8. Write down the remaining digits. Subtract this 8 from this. So what I get is 1, 4, 1, 3, 3. If you notice that this digit or this number is divisible by 7, then stop here. Otherwise, repeat the step. Truncate it, multiply by 2. I have 3 2 just 6. Write down the remaining number, subtract the 6, and I have 1407. Now this number is clearly divisible by 7. Stop here and you are done. So that means this number is divisible by 7. Alright? Okay, so this is a bit about divisibility. So if you still not get it, pause the video, go through the examples, read them, and then move on. Divisibility test of 5, simple, ending with 5 or 0. Now let us check some examples on divisibility test. So example 1 is 1 2 3 4 5 6 7 8 9 divisible by 2, B 732 divisible by 3, C 989 divisible by 9. Go through these examples, solve them, and then resume the video for explanations. Example 2, example 3, and the last one, example 4. So I'll again recommend pause the video, go with the solutions, and then we'll see the explanation. Try to solve them once on your own. So I hope you are done. So let's see the solutions. So this number 1 2 3 4 5 6 7 8 9, clearly the last digit I have to check. When I'm checking for 2, it is not divisible by 2, hence the answer is no. Go with this number, add up the digits. 7 plus 3 gives me a 10, plus 2 gives me a 12. Divisible by 3? Yes, so the answer is yes. 989, add up the digits. 9 plus 9, 18, and 8, 26. Not divisible by 9, hence no. Alright, hope you are comfortable applying the basic divisibility rules. Moving to example 2, is the number divisible by 6? Number is divisible by 2. Okay, so if I'm looking for a number that is divisible by 6, that means it must be divisible by 2 as well as it must be divisible by 3. Suppose if I have a number 18, it is divisible by 6. It definitely have a 2 in it and have a 3 in it. So this is the way how to check the divisibility from the composites. So if I want to check the divisibility by 6, check with the 2 and the 3. So number is divisible by 2, but it does not tell me anything that the number is divisible by 3 or not. So I cannot be sure that it is divisible by 6 or not. For example, 4 is a number divisible by 2 but not by 6. On the other hand, 12 is a number divisible by 2 and 6 also. So this alone is not sufficient. Similarly is the case with second. It tells me that it is divisible by 9 and hence it is definitely divisible by 3. But what about 2? I am not sure that the number is divisible by 2 or not. But when I club these statements, this tells me that the number is divisible by 2 and this tells me that the number is divisible by 9 or 3. So hence the answer is C. Both statements together are sufficient, but neither alone is sufficient. And go to this third example. If we are given a statement that the number is divisible by 6, okay, that means again the number is of the form of 6k, and I know it is definitely divisible by 2 and definitely divisible by 3. So this is definitely true. Even, it is divisible by 2, so hence it's always going to be even. Divisible by 12? No, I cannot be sure about it. It can be a 6 or it can be a 12. Both of the numbers are divisible by 6. This is divisible by 6 but not by 12. This is divisible by 6 and 12 both. So this is not always true, but these two are always true. Example 4, a, b and c are integers. Is the number 3a plus b plus c divisible by 3 or not? Let us check it. So if I have to check this 3a plus b plus c, just let's see the options. a plus b divisible by 3 and c is divisible by 3. Okay guys, so definitely 3 into a plus b has a 3 in it. So if I say plus c upon 3, it simply gives me a plus b plus c upon 3. So I do not care about this a plus b. I've got this into integer because this has already a 3 in it. So I am only worried about this c. I'm only worried that the c upon 3 turns out to be integer. And this is only true when c is divisible by 3. So this alone is sufficient, but not this one. So the answer is B, Bombay. So I hope the explanations are clear. Still, if they're not clear, just pause the video, read the explanations. The fourth one, just pause the videos wherever you want and go ahead with the explanations. So now let us see how to calculate the number of factors. Now that is one most important thing of this video. Okay, let us check. So number of factors. Let us try to find out the number of factors for 72. So guys, I know that 1 is definitely a factor of 72. And for 1, I have 72. 1 into 72 gives me a 72, correct? Similarly, if I have 2 as a factor, for 2 I have 36 also as a factor. 2 into 36 will give me a 72. If 3 is the factor, then 24 is definitely the factor. Similarly, if I have 4, I have 18. If I have 6, I have 12. Then if I have 8, then I have 9. So you may notice that the factors come in pair. That means I have even number of factors for 72 because every number has a corresponding another factor for him. 8 into 9 brings 72, 6 into 12 gives me a 72, similarly 4 and 18 and so on. So the numbers of factors, they are even, correct? Now let us see one more case. Let us check out the number of factors of 36. So what happens with 36? I have 1, I have 36. For 2, I have 18. For 3, I have 12. For 4, I have 9. Then comes 6. But 6 multiplied by 6 itself gives me 36. So every factor was coming in pair, but the number 6, which is the square root of 36, is alone. So that means this has the odd number of factors. And what is the special about this number? That it is a perfect square. That's why its square root remained single or remained alone. Hence, we come to a result that perfect squares are the only numbers which have odd number of factors. Rest all the composite number will have even number of factors because the factor will come in pairs as seen here in the case of 72. But when I come to 36, they are odd because 6 is left alone. I hope this is clear. Let's move ahead. So let us calculate now the number of factors of 120. So let me just show you one approach that how to calculate the number of factors because I cannot count them again and again. So let us write 120 and prime factorize it. So 120 can be written as 12 into 10. This 10 I know is 2 into 5 and further I can write this 12 as 2 square into 3. So this is how to prime factorize quickly. So now I can write 120 as 2 to the power 3 multiply by 3 multiply by 5. So now I'm looking for the factors of 120. A thing to notice over here is if I say that the number is of the form of 2 to the power a multiply by 3 to the power b multiply by 5 to the power c, where a ranges from 0 to 3 and b ranges from 0 to 1 and C ranges from 0 to 1. So any number of this form with these ranges of A, B and C is going to be a factor of 120. For example, if I take 2 to the power 1 multiplied by 3 to the power 1 multiplied by 5 to the power 1, this is definitely a factor of 120. You multiply this by 2 to the power 2, it will become 120. So I think so this logic is clear that 2 to the power A into 3 to the power B into 5 to the power C is definitely a factor of 120 if the A, B, C ranges from the value of 0 to 3, 0 to 1 and 0 to 1 respectively. So now let us see the possible combinations of A, B and C. So the number of combinations of A, B and C, number of numbers which are of the form of 2 to the power A, 3 to the power B, 5 to the power C following these conditions. So now let us see how many possible combinations are there. So A can take the value from 0 to 3 and hence 4 values. Similarly, B can take the values from 0 to 1 and hence 2 values. C can take 0 and 1, again 2 values. So how many combinations do I have? I have 4 multiplied by 2 multiplied by 2, and that accounts for 4 to the 8 to the 16. So that means 120 is going to have simple 16 factors. So the number of possible combinations of A, B and C, the number of factors. And clearly I have 4 here. A can take 0 to 3, 0 to 1 means 2, 0 to 1 means again 2. So I hope it is quite clear. So I can generalize one thing, that if any number n can be written as p to the power a multiplied by q to the power b multiplied by r to the power c and so on, where p, q, r are the prime numbers and a, b and c are the powers. So the number of factors can simply be given by a plus 1 multiplied by b plus 1 multiplied by c plus 1 and so on. As seen in this case, 3 plus 1 that is 4, 1 plus 1 that is 2 and 1 plus 1 that is 2. And why we are adding this plus 1? Because A can also occupy the value 0. Similarly for B and similarly for C. So the number of factors simply by this formula. So check here, factors of 120, we have got them to be 16 and this is the formula. Alright, so to do it quickly, just write down 120 as prime factors, 12, 10, breaking it down to 2 square and a 3, 2 into 5, I have 2 to the power 3 into 3 into 5. Apply this thing, the number of factors, 4 into 2 into 2 equals to 16 factors. If it is clear, then fine. Otherwise, go back, rewind the video and see it again. Okay, let us see this example, a beautiful one. It says, is the number a perfect square? Number of factors of the number is equals to 9 and 3 is the factor of number. Try it. Okay, you can pause the video and try it again if you're not done with it. Okay, so if the number of factors are 9, that means the number of factors are odd and hence the number is a perfect square. 3 is the factor, this does not tell me anything. The number can be 9, perfect square, 3 is the factor, a number can be 27. 3 is the factor, but number is not a perfect square. So statement 1 alone is sufficient, but statement 2 alone is not sufficient. So let us take an example and see the variations which GMAT can ask. So I have a number 7200 and I am looking for the number of factors, even factors, odd factors and so much of the stuff. You can pause the video and go through these stuff, what the question wants you. So first idea, let us just prime factorize 7200. So 7200, if I break it into prime factorizations, 100 into 72, this is a 10 square and hence 2 square and 5 square. 72 is 9, into 8, and hence 3 square into 2 cube. So I can say that 7200 is nothing but 2 to the power 5 into 3 to the power 2 into 5 to the power 2. Okay, so let us move on now. So total number of factors, again writing in the form of 2 to the power a into 3 to the power b into 5 to the power c. A can take 0 to 5, that is 6 values. B can take 0 to 2, that is 3 values. And C can take 0 to 2, that are again 3 values. So I have 6 into 3 into 3. So 18 3s are 54. So 54 total number of factors. So let's check. Number of factors, 54. Yes, it's correct. Now looking for the number of even factors. Now guys, what determines the even factor and what determines the odd factor? Just look here. So if I look for even factors, that means there is definitely a 2 lying there, right? Because if I say that 2 to the power a into 3 to the power b into 5 to the power c, this is a factor of this number where of course a is less than equals to 5, b is less than equals to 2 and c is less than equals to 2. This is even if at least I have one power of 2. Else every number will be odd and the product will be odd. This is odd only if a becomes 0 and hence 2 to the power a becomes 1. Correct? Because if I give a at least even a single value, it will make this whole number even. So let us look for the odd factors. Then a can only take the value 0, b can take all the values from 0 to 2 and hence 3, and c can take all the values from 0 to 2 and hence 3. A is taking the value 0 and hence total value 1. So I have 1 into 3 into 3, that is 9 factors. So these are odd factors, and total number of even factors, simple 54 minus 9, that gives me a 45 factors. So I hope it is clear. A was taking the value 0 and hence 1 value, B was taking 0 to 2, hence 3 values, and C also 0 to 2. So now every time the number will be odd. So these are possible combinations for odd numbers of 2 to the power a and 3 to the power b and 5 to the power c. So I have 9 odd factors and 45 even factors. So even factors 45 and 9. So number of factors divisible by 25, divisible by 40, divisible by 150 and so on. So here also it asks you the number of factors not divisible by 75. Find out the divisible by 75 and then subtract from the total number of factors. Factors not divisible by 24, find out the total number of factors divisible by 24 and subtract from the total factors. So let us just go ahead and look for the one number, and that is factors divisible by 25. So if the number is factor of this number 7200, it is of the form of 2 to the power a, 3 to the power b and 5 to the power c. Now it is a multiple of 25, it definitely has a 5 square in it. So now again count the values of a, b and c. A has the values from 0 to 5 and hence total 6 values. B has the values from 0 to 2 and hence total 3 values. But what about the C now? 7200 can take a maximum power of 5, that is 2, and we have already given it here. So now C have only the chance of taking a value 0, because if I give 1, it becomes 5 to the power 3, hence not in scope of 7200. So it can take only one value, that is 0. So the total number of values C can take is 1. So I have a 6 into 3 into 1, that are 18 values, which are multiples of 25 and factors of 7200. So 18. Similarly, you can do for 75 and 24, 150 and 40. I hope this is clear. If not, go back again, see for 25, try for the others, match your answers from the answer key. Okay, so let us go with another example. Is x an even integer? Statement 1 says x is the square of an integer. Statement 2 says x is the cube of an integer. So you can pause the video and try to solve it. Okay, let us see the solution now. So x is the square of an integer. That means x is of the form of k square. Now, if k is odd, then x is odd. If k is even, then x is even. So I am not sure that x is even or odd. For example, if k turns out to be 1, k square is 1 and x is 1, hence odd. If k turns out to be 2, k square is 4 and x is 4 and even integer. So I cannot be sure. Similarly, go with the second statement. It says x is in a cube of an integer. So x is c cube. Again, if c is odd, x is odd. If c is even, x is even. So I'm not sure. Combining the statement, I have it is a perfect square as well as a perfect cube. So x is the form of, say, t to the power 6. It is a perfect square. It is a perfect cube. Again, depends if t is odd, x is odd. If t is even, x is even. Because I know that odd to the power any number gives me an odd if it is integer. And odd to the power every number is odd, even to the power any number is going to be even. So the answer is E. Both the statements are not sufficient. Let's move on to the last example for today. I have this number. You need to calculate the number of factors, which are multiples of 120 and factors of this number. So pause the video and you can move ahead then. Okay, so if you're done with it, let's see the explanation. So here is a catch over here. I have a 10 over here. Correct? So I cannot just multiply the powers. I have to break it into the prime numbers. That is necessary. A, B, C, and D have to be in prime numbers. So I'll say that this prime factorization is 2 to the power 8 into 3 to the power 6 into 5 to the power 4. And this 10 I'm breaking into 2 and 5. So I have 2 to the power 5 multiplied by 5 to the power 5. And hence I have 2 to the power 13, 3 to the power 6, and 5 to the power 9. So this is the prime factorization of the number. Now the number is a multiple of 120. Now I know that 120 is nothing but 12 and a 10. This is a 2 and a 5. And this is 2 square and a 3, which gives me 2 cube, a 3, and a 5. So the number which is a multiple of 120 is of the form of 2 cube, 3, and 5. And factor of this number, so is of the form of 2 to the power a into 3 to the power b into 5 to the power c. Now how many values can a take? 3 are already there, maximum will be 13. So I have options of 0 to 10 and hence 11 values. Remember 11 because I'm counting 0. Go with B, 1 already there. I have total in my hand 6. So 0 to 5 visible and I have 6 values. Go with the C again. I have 1 over here. Total possible values of 5 can be 9. So I have 0 to 8, hence 9 values. So 9 6 gives me 54 and then multiply by 11 gives me 594. The total values 594, multiple of 120 and factor of this huge number. So the answer is C. So that is it for counting the number of factors. Hope you liked the video and we'll continue with the remainders and the trailing zeros, factorials and maximum powers in the next video. Thanks for watching it and have a good day.